Hey guys, in this lesson we're going to talk about central tendency and dispersion. We're going to have three learning targets. Number one, we're going to review what measures of central tendency and dispersion mean. We're going to talk about finding missing data values when we're dealing with the mean. Measures of central tendency are ways that we describe the center of data. So imagine that we had some data here, 6, 7, 8. These are ages of children that we came across on a playground or something like that. And then we have one maybe 36-year-old child that we find on the playground. So measures of central tendency are ways that we can kind of describe where the center of the data is. Now, we have certain things that are called outliers. If you notice, all our data, all of our ages are kind of clumped up right here. Then we have this one person who just finds their way onto the playground. Maybe they're walking through or wandering through, and that person's 36 years old, right? So when we find our different values, that is an outlier. That's not normally what you're going to find. Outliers are important because they affect our mean. So very quickly, I can't spend a ton of time on it, but let's review the mean, median, and the mode. The mean is when you add all the values up, then you count them up and divide by that total number. So I used to tell my kids kind of this rhyme: add them up, count them up, then divide. You got to add them up, count them up, then divide. So you add all the numbers, and you count up how many numbers there are, and you divide by that number. You can see that there. We use the mean to describe the middle of a set of data that does not have any outliers. So an outlier will throw off your mean pretty badly. If you imagine adding all these up, and then you add in 36, and you divide by the total number of numbers, in this case 7, you're going to get a number that's probably above 10. But most of our data is not in that area. Most of our data is over here, so it's not really the center. So we don't want to use the mean if we have outliers. Median, that's the actual middle value in a set of data. So if we were to find the middle, there are 7 data items here. If we were to find the middle, we would choose this one right here. This is the middle data item, right? And we use the median to describe the middle of a set of data that does have an outlier. So in this case, our median is 9. And a mode is what you count up when the data are non-numeric, which means you might have a list of animals, and you might have lemurs, zebras, whatever else, and they're not numeric. You want to find the mode, the one that occurs the most, or if you're choosing the most popular items. So if you're counting shoes in your classroom, and some people have Yeezys, and some people have Nikes, and some people have Vans, if you find that the most popular item is Vans, then you're going to count them all up and see how many Vans there are. And that pretty much describes all our different measures of central tendency. So just to quickly review, calculating the mean, you add them all up, you count how many there are, 1, 2, 3, 4, 5, 6, 7, 8, and then you divide by that total number, and that gives you your mean or your average. The median, we put all the numbers in order, we find the middle number. If there are 2 of them, then we add those 2 together and divide by 2. And finally, the mode, we just count up the ones that occur the most, right? In this case, our mode, it looks like, is 104 because there are 3 occurrences. A data set can have no mode, right? It can have no mode. If none of the items occur more than once, then there's no mode. And it can have multiple modes. In our data set, if we had 3 occurrences of 117 as well as 3 occurrences of 104, then the mode would be 104 and 117. In this problem, we're finding a missing data value in a set of data items. So your grades on 3 exams are 80, 93, and 91. What grade do you need on the next exam to have an average of 90 on the 4 exams? So you remember your formula for finding the average or the mean. We took all the different data items, and then we added them together, and then we counted up how many data items there are. In this case, there's 4, and that would give us, when we divide the top by the bottom, we get our mean. Go ahead and do that for this particular problem. We'll take 80 plus 93 plus 91 plus a 4th score that we don't know what it is. So we'll use a variable to replace that. So we'll add in an x there. And since there are 4 scores here, there are 4 scores, we'll go ahead and divide by 4. Now, we're going to go ahead and solve for x because we know that the average is 90. That's supposed to be equal to 90. We can solve for x here. We'll need to first add up 80 plus 93 plus 91. We get 264. 264 plus x over 4 is equal to 90. And then our first step, we're going to be doing just basic algebra stuff, right? We see that we want to get rid of this 4 down here, so we're going to multiply by 4 on both sides. That's going to give us, on the right-hand side, it's going to give us 360. Over here, it's going to cancel out our 4's. So we'll have 264 plus x is equal to 360. And we're almost done. We can just subtract 264 over here, then subtract 264 over here to keep it balanced, right? That'll cancel that out, and x will be equal to 360 minus 264, which is 96. And that is our value. That would be the score that we would need to make sure we have an average of 90 on the 4 exams. It's a pretty practical application of a problem for students. We've talked about measures of central tendency. We also need to talk about measures of dispersion. And some people might call that a measure of variance. And both of those are words that mean spread, right? So dispersion and variance, they're both words that mean spread. So we're trying to figure out how the data spreads out from the center. Before, we were trying to describe the center of the data. Now we're trying to describe how the data spreads. And there are different kinds of things that we use to measure that. We can use the range. We'll talk about that in a moment. You might have remembered interquartile range, mean absolute deviation from 6th grade. And then standard deviation is something you'll get into later. Range, which is what we're concerned about, is the difference between the largest and the smallest data items. So let's go ahead and use this example to solve some range problems. The closing prices in dollars of 2 stocks for the first 5 days in February are shown below. So these are our closing prices. What are the range and the mean of each set of data? Use the results to compare the data sets. So here we go. We'll find our range first. We want to find our largest and smallest numbers. Well, our largest number is 47, right? So we'll put that in there, 47. And then our smallest number is 25. So to find the range, all we have to do is subtract those two. So 25 to 35, that's 10. And to 45, that's 20 more. And then 2 more, that's 22. So 47 minus 25 gives me 22. Then we'll find the range for the second set of data. What's our largest number? In this case, is 36. And our smallest number, in this case, is 28. So 36 minus 28 is equal to 8. So we have 2 different ranges here. Then we also want to find the mean. So to find the mean, we're going to add these up all over the total number of data items, which is 1, 2, 3, 4, 5. And the same thing over here. That's going to give us a median of 32, mean of 32. And then on this side, we can subtract. We know we've got our range here, all over 5. And our mean is also 32. So in order to compare these two, we find that our ranges are rather different, right? They have a broader range. The data is spread out more, but the mean, the center of the data, is the same. So our measures of spread or dispersion are different from our measures of center.